The moon has no atmosphere, no gravity, and is perfectly round. These are some of the most popular beliefs about the moon, but how true are they? For centuries, the moon has been the companion of our night and the protagonist of countless stories. Its brilliance inspires but also deceives. Even today, in the midst of the era of space telescopes and interplanetary missions, myths and beliefs around that distort what we really know about our satellite. On this trip, we will explore the 7 most popular beliefs about the moon, which are actually lies. Let's get started. The moon has no atmosphere. For decades, the idea has been that the moon has no air or atmosphere. While it's true that the moon lacks an environment in which we can breathe, saying that the moon has no atmosphere is an inaccurate statement. The thing is that the lunar atmosphere is nothing like Earth's, and that's why it was ignored for a long time. The moon possesses an exosphere, a skinny and tenuous gaseous layer so diffuse that the molecules rarely collide with each other. We would not be able to detect it, let alone breathe it, with conventional instruments or our eyes. Its pressure is so low, on the order of a trillionth of Earth's, that it technically borders on a vacuum. But it exists and plays a vital role in the interaction between the surface and the space environment. It is composed mainly of helium, neon, hydrogen, argon, and traces of sodium and potassium, in addition to particles released by the solar wind. These gases are continuously expelled by radiation and replaced by processes such as soil outgassing, micrometeorite bombardment, and the interaction of the solar wind with lunar regolith. Although insignificant to human life, this exosphere has profound scientific implications. It influences how lunar dust behaves, affects telescopic observations, and could even interfere with equipment on future missions. Thanks to probes such as the Lunar Atmosphere and Dust Environment Explorer, or LADEE, we now know that the moon is not a completely inert body, but a world that, even without air in the traditional sense, has its own invisible breath, an exosphere that surrounds it and is present in every corner of its surface. We always see the same side because the moon does not rotate on its axis. One of the most widespread misconceptions about our satellite is the idea that the moon does not rotate. The phrase, "we always see the same face," leads many to believe that its surface remains static, as if it were a motionless disk orbiting the Earth without rotating. But the reality is much more elegant. The moon does rotate on its axis, and it does so in perfect synchronization with its orbital motion. This phenomena is called synchronous rotation, and it is the result of billions of years of gravitational interaction. In the past, the moon rotated faster, but the Earth's tidal force gradually slowed its rotation until it equaled the time it takes to complete an orbit, about 27 days and 7 hours. This balance means that the moon always shows the same face towards us, but not because it is still, but because it rotates at the same rate as it advances around the Earth. A simple way to imagine it is to hold a ball and spin around a lamp while still looking at it. If the ball didn't rotate, at some point it would show the other side. The fact that this never happens with the moon is proof that it does rotate. In addition, due to a slight swing called libration, we came to observe around 59% of its total surface. Therefore, the idea that the moon does not rotate is not only wrong, but contradicts one of the most precise and fascinating dynamical balances of the Earth-Moon system. The far side of the moon is in complete darkness. Few phrases have caused as much confusion as the dark side of the moon. It sounds poetic, mysterious, even mystical, but it is scientifically incorrect. No side of the moon remains in perpetual darkness. In fact, its entire surface receives sunlight throughout a lunar month, in the same way that the Earth alternates between day and night. The confusion arises because the moon always keeps the same face facing the Earth, as we mentioned in the previous point. So, for millennia, humans only saw one half of the moon. It wasn't until 1959, when the Soviet Luna 3 probe sent back the first images of the far side of the moon, that the far side ceased to be literally unknown. But hidden does not mean dark. When we see a new moon from Earth, that is, when its near side is in shadow, the far side is entirely illuminated by the sun. The error persists because the terms dark and hidden were used interchangeably for years, even in scientific texts. However, the far side of the moon has its own sunrises and sunsets, only they are never visible from Earth. Interestingly, that hidden hemisphere is very different. It's cratered and has thicker crust with almost no basalt plains like the ones we see on the near side. Its historical isolation gave it a reputation for being mysterious. Still, today we know that far from being a kingdom of eternal shadows, it is a landscape illuminated by the same sun that illuminates our days on Earth. Hey Curious Squad, before moving on, be sure to subscribe to our channel, clicking on the notification bell, and leave us a thumbs up so you don't miss out on our daily videos. The moon is perfectly round. To the naked eye, the moon looks like a perfect sphere suspended in the sky, a flawless circle that has inspired poems, calendars, and mythologies. However, that appearance is an illusion of distance. In reality, the moon is far from perfectly round. Its actual shape more closely resembles a slightly flattened ellipsoid, or even a misshapen egg with a bump facing the Earth. This asymmetry is not accidental. It is due to the Earth's gravitational force, which over millions of years generated a phenomenon called tidal coupling. As the moon cooled and solidified, the Earth's pull warped its mass, creating a permanent bulge on the face we always see. This bulge causes its center of mass to be displaced about 2 kilometers towards our planet, which also helps to stabilize its synchronous rotation. In addition, the lunar surface is irregular. Denser areas known as mascons and ancient basaltic seas alter the gravitational balance and overall shape. Precise measurements from probes such as the Lunar Reconnaissance Orbiter, the LRO, and the GRAIL Gravity Recovery and Interior Laboratory mission reveal that the moon has a slight ovality, wider on one side than on the other. Thus, the image of a perfectly spherical satellite belongs more to the realm of aesthetics than to science. What floats above our heads is a body shaped by time, tides, and impacts, an imperfect sphere that keeps in its deformations the history of its relationship with the Earth. The moon is white and bright. When we look at the moon on a clear night, it looks like a white lighthouse suspended over the world. Its light is so intense that it can cast shadows, illuminate landscapes, and even inspire verses. However, this visual impression is deceptively false. The moon is neither white nor especially bright. In fact, its surface is dark gray with brown, blue, and yellowish tones depending on the mineral composition of the soil. The basalts, rich in iron and titanium, which form the lunar seas, have a more bluish hue. The mountainous regions composed of an orthosite are lighter and slightly golden. If we could see it outside the contrast of the night sky, the moon would appear surprisingly dark, almost the color of asphalt. Its apparent brightness comes from reflected sunlight, but the moon only reflects about 12% of the light it receives, a value called albedo. For comparison, snow reflects more than 80% and water about 10%. The fact that it looks so resplendent is because we observe it on a black background, without visual references of brightness, which deceives our eyes. In addition, the lunar surface produces an optical effect known as oppositional surge, a sudden increase in brightness when the sun is just behind the observer. This phenomena, combined with the absence of an atmosphere that scatters light, makes the moon appear like a perfect mirror. In short, the moon does not shine by itself, nor is it as white as we imagine it. It is a gray and dusty world whose beauty comes precisely from that austere mineral simplicity reflecting the light of the sun. There is no gravity on the moon. Images of Apollo astronauts slowly leaping over the lunar surface gave rise to a mistaken but persistent idea that there is no gravity on the moon. In reality, lunar gravity exists and is perfectly measurable. It is much weaker than Earth's, about 1/6. On Earth, an object weighing 60 kilograms would exert a force of about 10 newtons per kilogram. On the moon, the same object would weigh only 10 kilograms. That's why the astronauts seemed to move in slow motion. They didn't float, they just weighed less. The lunar gravitational pull is 1.62 meters per second, enough to hold both the space modules and the dust kicked up by the boot steady. This reduced severity has significant consequences. On the one hand, it makes it easier to launch vehicles into space. Less energy is needed to take off. But on the other hand, it represents a biological challenge. The lack of prolonged gravitational load can deteriorate muscles, bones, and cardiovascular systems. Future lunar bases will have to incorporate technologies or routines that simulate Earth's gravity to preserve human health. In addition, the lunar gravitational field is not uniform. There are regions with slight variations called mascons, mass concentrations, remnants of ancient impacts that alter the local balance. These anomalies even affect the orbits of the probes. So, far from being a place without gravity, the Moon has its own gravity, enough to maintain its shape, retain a faint halo of particles, and remind us that even on the quietest worlds, physics is still inexorable. During the full moon, people behave differently. The idea that the full moon alters human behavior is as old as history itself. From ancient civilizations to modern popular culture, this lunar phase has been associated with madness, violence, insomnia, and even increased births. The word lunatic comes from this belief, and even today, many people swear to feel its effects. However, science has shown time and time again that there is no solid evidence to support such claims. Various psychological, biological, medical, and statistical studies have analyzed millions of records of emergencies, births, and crimes, looking for correlations with the phases of the moon. The results are consistent. There is no significant relationship. The natural variability of human behavior is enormous, and any coincidence with the full moon is usually due to confirmation bias. We remember the cases that fit the belief and forget those that don't. Even experiments on sleep show only a marginal difference, attributable to more ambient brightness or cultural expectation than to a gravitational or biological effect. The lunar influence on humans is essentially symbolic, not physical. The fascination aroused by this belief comes from the fact that the moon does not profoundly affect the Earth. It regulates the tides, stabilizes the planetary axis, and determines natural cycles. But its impact on our emotions or decisions is, as far as science has been able to measure, nil. What persists is the magic of myth, the human need to find in the moon a mirror of its own inner mystery. By debunking these myths, we discovered that the real moon is far more fascinating than any fiction. A dynamic body full of contrasts and mysteries yet to be solved. She is not white, nor perfect, nor immobile. She is a silent witness to the history of the Earth and the solar system. Understanding it rigorously does not reduce its charm, but rather amplifies it. If you'd like to know more interesting facts about the moons of the solar system, watch this video.